In this video, I'm going to show you how to factor a trinomial where your a term will be 1, but I want to show you ones that don't look like your a would be 1 because what you actually have is starting with a greatest common factor. And based on our flow chart in class, the greatest common factor you should always factor out first, and then you should decide what kind of polynomial you have. Now, I haven't done the other ones yet. I've only been working on trinomials where your front term ax squared is 1x squared. And I want to show you some examples where our front term is not 1, but I'm going to show you after you take the GCF out, it actually is 1. And so in these examples here, I want you to take a look at your 3 terms here. I noticed that all 3 terms are even. And so I'm going to divide all the terms by a GCF of 2. So I'm going to factor out the 2 first. So if I divide all those terms by 2, I'd be left with 1x squared. 18 divided by 2 would be 9x for my middle term. And 72 divided by 2 would be 36. And now what I want to do is factor, if I can, more, and find 2 numbers that multiply to make negative 36 and add to make 9. And so I'm trying to think of negative 36. What are factors of negative 36? There would be a factor of 9 and 4, 1 times 36, and then also 6 times 6. Now, if this is negative 36, one of those pairs is going to be negative. And so when I'm looking at 9 and 4, I want to think of 9 and 4 as negative 9 or and positive 4, or negative 4 and positive 9. There's also, I think I missed another pair there, 12 and a 3. And so I want to think about, you know, for 9 and 4, is it negative 9 and 4 or 9 and negative 4 because I have negative 36, or 1 and negative 36, or negative 1 and 36. Or negative 6 and 6, that won't matter which 6 has a negative, or negative 12 and 3, or 12 and negative 3. Which is the pair that adds to make 9? It would be a positive 12 and a negative 3 for our terms. So now that I found that one, just because I want to keep some space, I'm just going to kind of draw a line there to separate from my next one. So this would be our fully completely factored trinomial. And we did have an a equals 1 because we factored out that GCF of the 2 first. Now in this example, I notice that we have a 3 in the front. And so I'm going to see, are all of my terms divisible by a GCF of 3? And I believe that all 3 of those terms are divisible by 3. So I'm going to divide out the 3 here. 21 divided by 3 is 7. 36 divided by 3 would be 12. Okay, so now as I'm thinking of how this will completely factor, I want to think of 2 numbers that multiply to make 12. So like 1 and 12, or negative 1 and negative 12, or 2 and 6, negative 2 and negative 6, or 3 times 4, negative 3 and negative 4. Those are the factors that make positive 12. Now, the reason why I wrote negative is because I had to make negative 7. And I noticed that negative 3 and negative 4 will add to make negative 7. Oops, I wrote 7 because I said 7. But I really want the combination of the 3 and the 4 that are both negative to add to make the 7 middle term that we had. And this is our completely factored trinomial. Okay, here's 2 more. Each of these terms is also divisible by a GCF, a greatest common factor of 3. So I'm going to divide that out. I'm left with 1x squared plus 1x minus 60 divided by 3 would be 20. And so now what numbers multiply to make 20? 5 and 4, a negative 5 and a 4, or a 5 and a negative 4. Actually, this pair won't work because they're both positive. Which of those pairs, or, 10 and negative 2, negative 10 and 2, which pair is going to combine to make 1? Well, that pair is going to be a positive 5 and a negative 4 pair. Okay, we have only one more. This one is going to have a slightly more complicated GCF because I noticed there are some letters that every term have that we can take out. All of these terms are divisible by 7, and out of the letters, the smallest power that I see is the cube. I'm going to take that cube out from every term here. And so my GCF is going to be out in the front. And now I'm going to divide that out of every term. 7 divided by 7 is 1. X to the 5th take away 3 would mean I have 1x squared, which is what I told you we'd have. And then my middle term, 21 divided by 7 is 3. If I had 4 x's and I take 3 away, I'm left with 1x. And then 28 divided by 7 is 4. If I took all 3 x's out, there are no x's that remain. Now what numbers multiply to make negative 4? Well, 1 times negative 4, negative 1 times positive 4, or a negative 2 times a positive 2. Out of those combinations, what two numbers multiply to make negative 4, but at the same time add to make positive 3? It's going to be a positive 4 combo and a negative 1. And it doesn't matter the order of which you put these. It does matter that your GCF is out in the front, but this would also be a correct answer. So as long as one factor has a 4 that has a plus sign, one factor has a 1 that is a minus sign, and this is your completely factored trinomial.